Okay, welcome today. I want to discuss this article I recently finished on Einstein's alleged proof of invariance of spherical light waves in special relativity. Now, the subject of this brief note is Einstein's alleged proof of the Lorentz invariance of spherical light waves in his special relativity theory. These are at the very foundations of special relativity. This is basically year zero stuff, level zero. 0 day kind of proof. Absolutely basic. Now, our purpose is to describe a positive gap in this proof. There's a gap. The gap cannot be closed. So, we have two goals. One, to show that his proof is incomplete, and finally, that his conclusion is invalid. Now, the purpose of Einstein's alleged proof is to reconcile the two fundamental assumptions of special relativity. One, his so-called restricted relativity, that the laws of physics are the same in all reference frames. Non-accelerated reference frames. The way he writes it, it's that the laws of physics should be the same. And in a way that makes sense. I mean, we're different physicists, go in different directions. We need something we can agree on. We need some common terms. For Einstein, these common terms were the laws of physics. In other words, some kind of formal properties of math that supposedly, I guess, all physicists share. You could say that it requires all reference frames, KK prime, all physicists to be using the same formal laws. That in itself is a type of metaphysic. Second assumption is that light in vacuum propagates along straight lines with constant velocity. Now he calls this second condition the law of propagation of light, and as it's being a law, it should be subject to A1, that the laws should be same forms in all reference frames. In Einstein's own words, there is hardly a simpler law in physics than that according to which light is propagated in empty space. Every child at school knows, or believes he knows, that this propagation takes place in straight lines with velocity. Who would imagine that this simple law has plunged the conscientiously thoughtful physicist into the greatest intellectual difficulties? Again, notice the occurrence of a law in the above quote. So Einstein assumes that his second, the law of propagation, is a law. However, the conjunction of A1 and A2, which we'll just abbreviate A12, is contradictory according to classical mechanics, like Fizot's law of addition of velocities, to say the least. It has other problems. However, Einstein claims, and this is popularly lauded as among his greatest intellectual achievements, that this is only an apparent incompatibility, and which is resolved by postulating the Lorentz transformations. Well, it is resolved by postulating that Lorentz transformations relate the measurements of space and time coordinates in the reference frames KK prime. But we submit that Einstein's argument is incomplete and his conclusion incorrect. Einstein's error in the first steps of his theory has been elaborated by other authors, notably Bryant and Crothers, and I spent some time reading their papers, but it's such a controversial issue that the proofs need to be as clear and as simple as possible. The argument needs to be made plain, because when you bring this up to other people, they want to dismiss you. It's basically a logical impossibility for them that Einstein could be wrong. So you have to go very slowly and state things in fashion that they just cannot deny. So I was attempted to try and identify in plain, the simplest terms, what the problem is. First, we could say Einstein confuses quadratic expressions like equation 1 here with the equation of a sphere. If you got x, y, z, t, just variables, really not even any physical meaning anymore, then this sort of quadratic expression, it does not represent a sphere. I mean, to begin, It's a three-dimensional cone in the four variables. Yes, it contains numerous spherical two-dimensional subsets, but they have other properties. For instance, the radius should, again, it's not the radius, in this case tau should be constant, have constant derivative with respect to variations. In other words, the left-hand side of that equation 1 should be constant in order that this actually represent a sphere. I mean, in simple terms, you can imagine non-spherical subsets of the cone, and they would all satisfy this equation, except for example, the left-hand side would probably not be constant. That's kind of our point here. You have Lorentz invariance, but to have spheres mapped to spheres, there's certain quantities that have to be constant. But under the Lorentz transformation, there's not very many Lorentz invariant quantities. So we could say, this is really, again, the key sentence, it'll be repeated later. The Lorentz invariance of the Minkowski form in no way implies the Lorentz invariance of the other smaller forms. No. So look again at this expression. Yes, this is the Lorentz invariant expression. But that does not mean that the left-hand side and the right-hand side are invariant quantities. No. What it means is that the difference between the left-hand side and the right-hand side will be constant, but the quantities themselves are not constant. This is the mistake. Now we get into some analysis here. There's a little bit of math to do, since we might as well prove a math theorem. Now, Einstein's argument concerns the geometry of a wavefront generated by a light pulse, i.e. we're brought to study the action of the Lorentz group on subsets of the null cone. Obviously, the null cone's Lorentz invariant, and yes, satisfies this equation. Again, that's the same equation as 1. Basically, it's the null cone. It's an invariant subset. But here we get a basic theorem. If Q is a quadratic form on R4 such that the restriction is G invariant, the restriction to the null cone, then Q is proportional to H. That is, the Minkowski form is the unique Lorentz invariant quadratic form, modulo scalars, on R4. Maybe I should correct it. It's the unique form that vanishes on the null cone. Basically unique. The argument here can be a little interesting, just as it appeals to Hilbert's Nullstellensatz, which is a result of algebraic geometry over the complex numbers, which is the algebraically closed field, so-called. That argument's basically taken from a paper of J.H. Elton. The link is provided in the back. So now let's return to the subject at hand. What we just established is what we got here in bold. The Lorentz invariance of the Minkowski form and the null cone does not imply the Lorentz invariance of the forms H1 and H2. We repeated that, but now we kind of gave a formal proof. Now you could see that it does not imply the Lorentz invariance, or you can see that these are not Lorentz invariant, as we will illustrate in a two-dimensional example. But there's much more that's true. That's what the theorem is saying. The theorem is more abstract. Well, it's saying there's really no other quadratic forms, quadratic expressions you can speak of, which are variant under the Lorentz group. And especially, if the form is to vanish on the null cone, then there's definitely no others. There's only the Lorentz form. Now, you can go through this two-dimensional example here. It's just putting in simplest terms, showing that the conclusion of the Einstein theorem, of Einstein's proof, is not even correct. namely spheres don't get mapped to spheres. Now some people would argue, well, the effect of the Lorentz transformation is to map spheres to ellipsoids as defined by the Lorentz transformation, i.e. ellipsoids which have had length contraction in the direction of motion. What's the problem there? Well, there you're talking about material bodies, their motion. Yes, there's supposedly, according to the Lorentz transformation, its material bodies will have a contraction in the direction of motion. But we're talking about light waves. That's the whole issue here, and I can't reasonably think that there's any there's no material compression of the light wave. At least nobody talks about that. So in that way it's unsatisfactory. It doesn't answer the question. Again, I'll just say material spheres will be mapped, transformed by the Lorentz substitution to ellipsoids, but that is what happens to material bodies under motion according to this theory. What happens to spherical light waves, non-material, I don't think anybody's prepared to say. And actually, the content of assumption A2 is that, precisely, that spherical light waves will be mapped to spherical light waves. In other words, that the law of propagation of light is Lorentz invariant. We're arguing that no, there are no spheres in the null cone that can be mapped to spheres in the null cone. Now, we submit that this above argument positively demonstrates a gap in Einstein's purported proof. In other words, it's not a proof which has a sort of non sequitur in it. It's a proof that doesn't even establish anything true. It establishes falsehoods. So it's an incorrect proof, and it's incorrectly trying to prove a false result, namely that A2 is compatible with A1. Now here, you should be warned, the reader can consult Einstein's own words. Go read his book. You can verify he does not treat the general case, does one special example, finds that equation 1 up there, calls it an equation of a sphere, and thinks his work is done. My friend, no, you're not done. Now this gap has been investigated by other authors, more critical authors. There's Bryant and Crothers. And again, we were much influenced by reading their papers. I'll admit I read their papers in detail, but I spent a long time in doubt. I didn't really catch the point. And I definitely was not able to explain it to other people to persuade them. But in these terms, the way I've laid it out in this paper, I think you can make the case in very simple terms, at least to a mathematician. So mathematician to mathematician, I think the argument here is undeniable and very simple, and I think it brings out an interesting observation, namely our theorem, that really there are no other Lorentz invariant forms, quadratic forms, other than Minkowski's form. Now, yes, this is very controversial. There's other reasons to believe that actually A2 is incorrect, that there is no law of propagation of light. For one thing, André Cocteau-Zassis has a very good analysis of the inherent contradiction, incompatibility of wave-particle duality. Namely, it's known that a wave is independent of the motion of its source, but the wave is very dependent on the motion of its receiver. So there's an asymmetry there. Moreover, if you think of the particle viewpoint, then it's obvious that the velocity of the particle depends on the motion of the source. So you see, if light is supposed to be sometimes a wave, sometimes a particle, property A2 is a property that neither particles nor waves have. And in that sense, it demonstrates light cannot be seen as some sort of particle wave. It can be seen as neither of them. And Ralph Sansbury takes it even further in his book, faster than light, that whole assumption needs to be revisited. This assumption that light is something that travels through space, that light is like a particle that travels, or that light is a wave that travels. Sansbury's idea is that light does not travel at all. Rather, it's like radio receivers inside the atomic nuclei. It's sort of hidden from view. There's sort of resonances that happen. At some point, the resonances spill over to the electrons, the conducting electrons, and then those induce, at a distance, oscillations in the receiver, in the atomic receiver nuclei, which eventually spill over into the outer shells and then can be detected as radiation. So in that case, his theory is an instantaneous force at a distance, but it's cumulative instantaneous force. There's a time delay, and that time delay is what's called the speed of light, but there's not really any speed. There's no particle that's traveling. There's no meters per second unit. So, all comments are welcome. All criticism, rebuttals, thank you very much.